Imagine every drop of water on Earth, all the oceans, rivers, and lakes, vanishing in an instant, hurled straight into the blazing sun. Would it cool down? Would it explode? Or would something far stranger happen? Today, we're diving into this ultimate cosmic what-if scenario. Imagine standing on the shore of the Pacific Ocean, staring out at what feels like an endless body of water. Now multiply that by every sea, every river, every lake, and every drop of groundwater on Earth. Together, all of this makes up Earth's total water supply, which scientists estimate to be about 1.386 billion cubic kilometers. That's a number so big, it's almost impossible to visualize. To give you a picture, if you poured all of that water onto the United States, it would cover the entire country with a layer of water nearly 10 kilometers deep. Water is the foundation of life on our planet. It drives our climate, shapes our landscapes, and sustains every living thing we know. But in this video, we're not talking about life or survival. We're asking a much bigger question. What if every last drop of water on Earth suddenly disappeared from our planet and was dumped directly into the sun? Would it fizzle out like a giant campfire doused with a bucket of water? Or would something far stranger happen? To start, we need to put things into perspective. The sun is not just big, it is unimaginably massive. Our star makes up more than 99.8% of the total mass of the entire solar system. In fact, you could fit about 1 million Earths inside the sun and still have room to spare. Compared to that, Earth's oceans are a microscopic splash. If you placed Earth's total water supply next to the sun, it would barely register. But even so, the thought experiment is fascinating. Water is one of the most powerful forces on Earth. It carves valleys, sinks ships, and extinguishes fires. Firefighters know water as the ultimate weapon against heat. So it's natural to wonder, could water have the same effect on a star? Could we, in theory, put out the sun by flooding it with all the water our planet has to offer? Here's where things get interesting. The sun is not like a campfire or a candle. It doesn't burn in the same way. Instead of using oxygen and fuel like flames on Earth, the sun is powered by nuclear fusion. At its core, hydrogen atoms are forced together under extreme pressure and heat, fusing into helium and releasing incredible amounts of energy. This process has been going on for more than 4.5 billion years, and it will continue for billions more. So when we imagine dumping Earth's entire water supply into the sun, we're not throwing water onto a flame. We're adding more hydrogen and oxygen into a nuclear furnace. And this simple difference changes everything about how the event would unfold. Still, the question remains, if Earth's oceans suddenly vanished into the sun, what would actually happen in those first few moments? Would the water even survive long enough to reach the sun's surface? And if it did, what kind of chaos would erupt when one of the universe's most life-giving substances collided with one of its most destructive forces? The instant impact. So, what would happen in the very first instant Earth's entire water supply reached the sun? Let's imagine the moment of impact. Billions of cubic kilometers of water hurtle toward the sun at unimaginable speed, pulled by its intense gravitational field. As the first molecules approach the sun's outer layer, known as the photosphere, they encounter temperatures of about 5,500 degrees Celsius, or roughly 10,000 degrees Fahrenheit. That's hot enough to melt steel instantly, and far beyond anything we could replicate on Earth's surface. At those temperatures, liquid water doesn't even stand a chance. Before it can touch the sun's surface, it would flash into vapor. But here's the twist. It wouldn't just become steam like boiling water on a stove. The extreme heat would rip water molecules apart entirely. Each H2O molecule would split into hydrogen and oxygen atoms, separated by violent collisions with plasma particles racing at incredible speeds. Now, you might think that this would cool the sun down, like dousing flames with water. But the sun doesn't work like a flame. The oxygen wouldn't smother the star. Instead, both the hydrogen and oxygen would become part of the sun's churning plasma soup. And in fact, that hydrogen is exactly what the sun craves. Remember, hydrogen is the sun's fuel. Adding more hydrogen is like tossing gasoline onto a fire, not water. But before the sun could use it as fuel, there would be chaos. The sudden addition of such an enormous amount of material would trigger turbulence across the sun's outer layers. Imagine massive shock waves rippling across the surface, like giant tsunamis of plasma rising tens of thousands of kilometers high. Sunspots would flare, solar storms would erupt, and the sun's magnetic field would twist and snap like an overstretched rubber band. The violence of this event would be staggering. As the water molecules are torn apart, oxygen atoms would temporarily combine with other elements in the sun's atmosphere, creating bursts of energy and strange chemical reactions. At the same time, the sheer volume of new hydrogen would increase local fusion rates in some regions, sparking sudden outbursts of radiation. This could produce solar flares, colossal explosions that shoot streams of charged particles across space. For Earth, if it still existed after losing all of its water, the sight would be apocalyptic. Solar flares could bombard the planet with deadly radiation, frying satellites, disabling power grids, and scorching the atmosphere. But the truth is, Earth wouldn't survive to see it. Without oceans, rivers, or even a drop of water left, our planet would already be a lifeless husk, stripped of the very substance that makes it habitable. And here's something even more shocking. As violent as this moment would seem, the sun itself would barely notice. All of Earth's water combined is like a drop in a cosmic bucket compared to the sun's mass. The star would experience turbulence, sure, but it wouldn't be quenched. If anything, it would grow just a little hotter, a little brighter, and a little more chaotic, at least for a short while. So in the first few moments, the grand dousing of the sun would look less like putting out a fire and more like setting off fireworks on a cosmic scale. Explosive, violent, and awe-inspiring, but ultimately, just another day for our unstoppable star. The science behind it. Now that we've seen the violent first moments of impact, it's time to dig deeper into the science. Why exactly wouldn't the sun go out if we dumped all of Earth's water into it? After all, on Earth, water kills fire instantly. So why not in space? The answer lies in understanding what the sun really is and what water is made of. At its simplest, water is H2O, two atoms of hydrogen bonded to one atom of oxygen. And hydrogen, of course, is the very thing the sun runs on. At its core, under unimaginable pressure and temperatures exceeding 15 million degrees Celsius, the sun smashes hydrogen atoms together through nuclear fusion, creating helium and releasing energy in the form of light and heat. So, if you add water to the sun, you're not starving the fire, you're actually feeding it. You're delivering more hydrogen, more fuel. It's like pouring gasoline onto a furnace, not water onto flames. The oxygen doesn't help either. While oxygen plays a critical role in combustion here on Earth, the sun doesn't burn in the same chemical way. In the sun's plasma environment, oxygen atoms would be stripped of their electrons and incorporated into the soup of charged particles without ever snuffing out the process. But how much of a difference would Earth's entire water supply really make? Let's do the math. The total mass of all the water on Earth is about 1.4 10^21 kilograms. That's a 1 followed by 21 zeros. Sounds massive, right? But the sun's mass is 2 pi by 1030 kilograms, a 1 followed by 30 zeros. That's 9 orders of magnitude larger. To put it in perspective, Earth's total water is only about 0.01% of the sun's mass, practically nothing. Think of it like this. Tossing all of Earth's oceans into the sun is the equivalent of spitting into a volcano. Sure, it makes a splash, maybe even a hiss, but the volcano doesn't notice. A sun is so vast, so powerful, that even the biggest things we can imagine from Earth barely scratch its surface. Still, there would be localized effects. Adding so much hydrogen all at once could trigger bursts of fusion in specific regions, creating violent solar storms and flares. These would radiate across space, potentially causing disruptions to any nearby planets. But in terms of the sun's overall lifespan and energy output, nothing would change. In fact, if you zoom out, you'll see that stars like the sun already absorb enormous amounts of material from space, comets, asteroids, and even entire planets during their lifetimes. Compared to those events, Earth's water is tiny. Our sun has swallowed far bigger meals before, and it will again. So the scientific reality is clear. Earth's water wouldn't extinguish the sun. It wouldn't even dent it. Instead, it would briefly fuel the sun's fire, adding a minuscule amount of hydrogen to its reserves. And in doing so, it reminds us just how small Earth really is in the grand scale of the cosmos. Effects on Earth, the solar system. Up to this point, we've been focused on what happens to the sun, but let's shift our perspective for a moment. What about Earth? After all, if every drop of water on our planet suddenly vanished and was hurled into the sun, what would be left behind here at home? The first and most obvious effect is catastrophic. Earth would lose its oceans, seas, rivers, lakes, glaciers, and even the water locked underground. In an instant, the surface of our planet would dry out completely. The lush blue marble we know would transform into a barren desert world. Without oceans to regulate temperature, Earth's climate would collapse almost immediately. Daytime temperatures would skyrocket, while nighttime temperatures would plunge. The delicate balance that keeps our planet habitable would be shattered. Now consider the biological consequences. Every form of life on Earth depends on water, from the smallest bacteria to the largest whale. Without it, ecosystems would collapse in minutes. Plants would wither, animals would perish, and humans would not survive even a single day. Our bodies are made of about 60% water. Without it, life as we know it is impossible. The disappearance of water would mean instant extinction for nearly every living organism on Earth. The atmosphere would also be devastated. Much of Earth's oxygen comes from water, either through evaporation cycles or from marine plants like phytoplankton. With the oceans gone, oxygen levels would plummet. The atmosphere would thin and eventually collapse, leaving behind a suffocating wasteland more like Mars than Earth. Without water to absorb carbon dioxide, greenhouse gases would spiral out of control, making the surface even more uninhabitable. On a planetary scale, the loss of water would change Earth's geology as well. The crust, no longer lubricated by water, would crack and shift. Volcanoes could erupt more violently. Earthquakes might increase. The entire surface would be reshaped by the sudden absence of one of its most important components. And what about the solar system as a whole? Strangely enough, very little would change beyond Earth itself. For the other planets, moons, and asteroids, it would be business as usual. The sun might flare briefly from the sudden infusion of hydrogen, but on the cosmic scale, that event would pass quickly. The other planets would continue orbiting as though nothing happened. This contrast is striking. For the sun, Earth's total water supply is hardly noticeable, a brief hiccup in its endless nuclear cycle. But for Earth, the consequences are absolute and final. The loss of water would erase life, atmosphere, and climate in a matter of hours, leaving behind a silent barren rock orbiting the same indifferent star. And that's the true lesson here. Water is not just a resource. It is the very essence of Earth's identity. Take it away, and our planet ceases to be a home. From space, Earth would no longer shine blue. It would become another lifeless world, indistinguishable from Mars or Mercury, orbiting a sun that never even noticed the sacrifice. The big picture takeaway. So after all this cosmic chaos, what's the big takeaway? What do we actually learn from imagining a scenario as wild as pouring Earth's entire water supply into the sun? The first lesson is about scale. To us, Earth's oceans feel impossibly vast. They stretch beyond the horizon, cover over 70% of our planet's surface, and hold more than 1 billion cubic kilometers of water. Yet to the sun, all of that combined is practically nothing. Our planet's total water supply would be swallowed, vaporized, and absorbed without the sun even blinking. The event would cause turbulence, sparks of chaos, and violent flares, but in the grand scheme of things, it would barely make a dent in the life of our star. That realization is humbling. It shows us just how small we really are. Earth is like a single drop in the ocean of the universe, and its greatest features, oceans, mountains, forests, and even life itself, are tiny details in a cosmic landscape. We often think of ourselves as significant, but when measured against the sun, the Milky Way, or the wider cosmos, we are less than a whisper. The second lesson is about fragility. While the sun wouldn't even notice the loss of Earth's water, our planet would be completely destroyed by it. Life would vanish instantly. The atmosphere would collapse. The blue Earth we know would turn into a brown, desolate wasteland. In a sense, this scenario reminds us how delicately balanced our world is, and how much we depend on a resource as simple as water to survive. But there's a third lesson too: curiosity. Thought experiments like this one aren't just fun what-ifs. They're a way of stretching our imagination and testing our understanding of science. By asking impossible questions, like what happens when oceans meet stars, we're forced to think about the nature of water, the structure of the sun, and fragile systems that keep Earth alive. These mental journeys push us to appreciate both the wonders of our planet and the mysteries of the universe. In the end, the image is unforgettable. Earth's entire supply of life-giving water poured into the furnace of the sun, evaporating in an instant, fueling a star that never even slows down. It's dramatic, explosive, and awe-inspiring, but also a reminder of our place in the universe. The sun is not something we can control, extinguish, or even influence in any meaningful way. It is vast, powerful, and eternal on a scale beyond human comprehension. So the next time you stand by the ocean, watching the waves roll endlessly toward the shore, remember this: to us, those waters are everything. To the sun, they are nothing more than a drop. And that contrast between our smallness and the cosmos's greatness is what makes questions like this so fascinating. And who knows? If pouring water into the sun barely makes a difference, what would happen if we went even bigger? What if, instead of Earth's water,